Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you how to fit a linear regression model that includes the interaction of two variables. One is continuous and one is categorical. I'm also going to show you how to test hypotheses about the predictors, estimate marginal predictions from the model, as well as create some plots of our model. I'm going to be using the NHANES2L dataset, and you can download this from the Stata servers by typing webuse NHANES2L. And here I've described the three variables that we'll be using in our model. BP systole is systolic blood pressure, and that's our continuous dependent variable. Age is age measured in years, and that's our continuous predictor variable. And then HLTH stat, or health stat, is health status. That's our categorical predictor. And notice that it has a value label attached to it, and so I've typed label list HLTH so that we can see the various categories of health status. So for example, 1 indicates excellent health, 2 indicates very good health status, and so forth. There is a missing value category here, .A, and that will automatically be removed from our model, so we don't need to worry about that. So let's begin by going to Statistics and selecting Linear Models and Related, and then I'm going to go to Linear Regression. And let's move this up here. In the Model tab for my dependent variable, I'm going to select BP systole. And then for my independent variables, I want to show you how to use this little box here. I'm going to click on this box with the 3 dots on it. And let's start off by just including a single main effect. So I'm going to select the predictor variable health status. So here it is, health stat. Now the C dot here, this little checkbox, that checkbox indicates that the variable is continuous, and health status is categorical. So we're not going to check that box here. We're not going to be using any time series operators, and we're going to ignore base for now. So let's click Add to var list, and this will add that to our list of independent variables. And now I can click Submit, and the dialog box creates the command regress, followed by BP systole, which is our continuous dependent variable. And then we have health stat, which is our categorical predictor variable. Notice that the dialog box added an I dot to health stat. That tells Stata that health stat is a categorical variable, and it will create indicator variables for us, so we don't have to. So that's what the I dot is. It tells Stata that health stat is categorical. So let's come back over here and add a continuous variable to our model. So if I go back and click that box, under variables, I'm going to select age, which is our continuous variable. Now it's continuous, so I am going to check this box underneath the C dot. And again, I'm going to ignore time series and base and all of that. So if I click Add to var list here at the bottom, that's added age to my var list. So if I click OK, now I can see that age has been added to my list of independent variables. So I'm going to click Submit again. And the dialog box now adds age to the independent variables in our model. And if I look at the coefficients, I can see the categories of health stat here as well as age, and then underscore cons is our intercept. So let's do one more thing here. Let's go back to independent variables and click that 3-dot box again. Now I'd like to add an interaction. So let's click interaction two-way here. And I'm going to add health stat. Here it is. And then I'm going to add age, and remember age is continuous. I'm going to check the box underneath C dot, and then click Add to var list. And what that's going to do is then add an interaction term between health stat and age. So let's click that and click Submit and see what that does. If I scroll back up here, the command is still regress, the dependent variable is still BP systole. Now notice that health stat, and then there's a little sharp here, a hashtag operator, and then C.age, that's been added to our list of independent variables. That's the interaction between health status and age. So the C dot that's been placed in front of age tells Stata explicitly that age is a continuous variable. So we want the interaction of age treated as a continuous variable and health stat treated as a categorical variable. Now why is there no I dot there? Well, we could have put an I dot there, but Stata is going to assume that variables in interaction terms, it's going to assume or by default treat them as categorical. So that's why the I dot isn't there, but we could type the I dot there if we wanted to. That's not a problem. We could also put the C dot in front of age over here, and that wouldn't be a problem. We'll come back and take a look at that in a moment. So let's look at a shorthand way of doing this. I'm going to delete everything from the independent variables list in the dialog box, and then click this little 3-dot box, and I'm going to delete everything from var list here as well. Let's look at a quicker way to do that. I can come in here and select two-way full factorial. And now I can select health status and age. And I'm going to check the box next underneath C. And now if I click Add to var list and click OK, and I'm going to click Submit, let's just go ahead and look at it in the results screen. Now the independent variable list is simply health stat with two of those little sharp operators or hashtag operators, and then c.age. That's a shorthand way of asking stata to include a main effect of health status treated as categorical, a main effect of age treated as continuous, that's the c dot there, as well as the interaction of the two. Okay. And so now if I look at my output, I see the main effect of health status here. I see the main effect of age, and then I see the interaction of age and health status here at the bottom. So I'm going to close this dialog box. Let's do one more thing here just to show you that this works. I can go back into my independent variables and explicitly type i.healthstat # c.age. And if I press that, that works just fine. So that's a shorthand way of specifying my model with all the interactions and main effects. Now, let's say that I fit my model and I want to test the null hypothesis that all of those health status coefficients are simultaneously equal to 0. One way I can do that is to type test parm i.hlt, let me make sure I spell it correctly here, hlt stat. And that will test that all of those health status categories or coefficients are simultaneously equal to 0 using an f-test. So we get our f statistic and our p-value. Another thing that we might want to do is test that the interaction between age and health status, that all of those coefficients are simultaneously equal to 0. Because if we look at the p-values, some of the individual interactions, for instance, very good in age, that's greater than 0.05. But good is much less than 0.05. Fair is less than 0.05, but poor is not less than 0.05. We can test all of those simultaneously again by typing parm. I just clicked it over here in the history window to put it back in the command window. And now I'm going to use that little hashtag operator and then c.age. So I'm going to test just the interaction term here. And so now what it's doing is testing that those four parameters are simultaneously equal to 0 using this f-test here at the bottom. So I get my f statistic and my p-value. So it's easy to test for interactions even when you have multiple categories and things like that. Okay. Now another thing that we might want to do is calculate or estimate some marginal predictions from our model. So let's go to statistics and go almost to the very bottom here where it says post estimation. So I'm going to select that. And the post-estimation selector allows you to do all kinds of things. You can do goodness of fit analyses, predictions, diagnostic plots, things like that. I'd like to create a margin, estimate some margins. So I'm going to expand the marginal effects menu here, marginal effects, estimated means, interactions. And let's just do something basic and low dimensional analysis. So I'm going to select that and click the launch button here. And that opens the margins dialog box. So let's start off just by looking at marginal predictions for health status. So health status is categorical, so I'm going to leave that there. And then select health status. For the analysis type, I'm going to select marginal means of outcomes for levels of covariate. And then I'm just going to click submit. And let's take a look at that and see what we get. So that the dialog box creates the command margins health stat, and that gives us marginal predictions for systolic blood pressure for each category of health status adjusted for age. Okay, note, recall that we had age in the model as well as the interaction of age and health status. So all of those things are in our model. And so these marginal predictions of systolic blood pressure are adjusted for age, even though we're only viewing them for categories of health status. And then we get standard errors and t-statistics and confidence intervals. You can't see that behind here, but I'll show you in a moment. Now, another thing that I could do is I could come up here and select continuous. Maybe I want to look at marginal predictions for a continuous variable. So here I can look at age, and I might want to see predictions of age at, let's say, maybe age 20 in increments of 10 through 80. So if I do that and click submit, now I get marginal predictions of systolic blood pressure for at age 20, 30, 40, 50, and so forth. So here in the output, at age 20, the marginal predicted systolic blood pressure is 113.437. And again, I get standard errors and confidence intervals and all that for it. Now again, this is adjusted for health status and the interaction of age and health status. So that's what I'm getting with these marginal predictions. Now here's something really fun that I can do. I can actually estimate the marginal predictions for all of it, including the interaction. So if I check this box that says interaction analysis with another covariate, the other covariate is categorical, and that covariate is health status, and I don't need to specify any points to estimate at. So I'm just going to select that, and then go ahead and click OK here. And what that's going to do is estimate marginal predictions for every category of health status at age 20, 30, 40, 50, 60, 70, and 80. The command is actually margins, health stat, and then comma at age 20 through 80 in increments of 10. And so if I look at my output, I get a lot of output here, right? So these are all predicted systolic blood pressure at 20 years old, and so for someone who's 20 years old in excellent health, 20 years old in very good health, and so forth. And again, I see my standard errors, t-statistics, p-values, and 95% confidence intervals for all of those predictions. Now, one of the fun things I can do now is I can plot those. So if I come back to the post-estimation selector, I'm going to select Profile Plots after Marginal Analysis and click Launch. And then I can choose which variables define the x-axis. So I'm going to use age to define the horizontal axis, the x-axis, and click Submit. And what this will do is create a graph where the horizontal axis is age, the vertical axis is predicted systolic blood pressure, and then I see a separate line for each category of health status: excellent, good, poor, very good, and fair. And they're all color-coded, and I see a point and a confidence interval around each predicted value of systolic blood pressure for each age and each health status category. One of the things that I might want to do is create separate graphs for each plot. So what I can do is come over here where it says create subgraphs for groups defined by variables. I could create separate graphs for each category of health status. So now I see a separate graph for each category. Or if I prefer, I can remove that, and I could create an entirely separate graph for health status. So now if I click Submit, I don't know if you can see that it did it so quickly, but it created actually 5 different graphs, one separate graph for each category of health status. Okay, and then I can go through and customize the axes and the title and other things like that. So let me close these here, and I want to show you a nice little trick. I'm going to come back over here to the history window and right-click and select All. So all of those commands are selected. And then I'm going to right-click and select Send Selected to Do File Editor. And what that does is it sends all of those commands to a do file, and I can save this and then rerun my entire analysis over and over again if I want. So I don't have to go back and click all of those buttons. The other thing is I can go through here and see what all of the various options are that I used, for instance, with my margins plots or with the margins command. So this is a handy way to learn the commands so that you can begin typing them and just typing do files. So that's how you can fit a linear regression model that includes a continuous predictor, a categorical predictor, as well as interactions. You can test those interactions, estimate some marginal predictions, and then create some plots. I hope this was helpful. Thanks for stopping by.